teachers are really keen on something which is a passion to them, then they're much more likely to communicate that to their children. And I think we've been missing some of the passion in maths lately.
3, 2, 1, go!
Today, maths specialist Isaac Anoom is visiting Shaftesbury Primary School in London to explore how a teacher's favourite hobby can bring numeracy to life for years 5 and 6. They'll be trying out a range of knitting-based activities devised by their teacher, Jenny Staver.
4, 3, 2, 1, stop!
Right, stop on the dot. When and why did you decide to use knitting as a vehicle for teaching maths?
I just thought it was another interesting idea to inspire the children, because our children end up sitting, working in books a lot of the time and having a very prescribed curriculum. And I think they've become aware of how much numeracy is a part of knitting.
This knitting race is a chance for children to apply their understanding of measurement, time, prediction and recording.
Right, now that we've finished our 2 minutes of knitting, on the record chart here, we've put that we're going to have a 6-minute prediction. Is there any way of me actually putting that prediction in now based on the results that we have got already? Yeah.
Because of this 2 minutes, we done 1.3 centimeters. If you times that by 3, that will roughly tell us the answer to the prediction.
Very good answer, well done.
I like the way that Isaac structured that particular activity.
Now what we're going to do...
There was a chance for the children to be very engrossed in the knitting, and then there would be some mathematical activity that would come out of it. And whilst he was doing that, he was heightening the suspense and the tension, because they knew that they were going to do some more knitting after that.
Tony, you've done 1.7 centimetres so far after 3 minutes. How much do you think you will have knitted in 6 minutes?
4.2.
4.2 centimetres, okay.
I disagree.
Why?
Because 1.7 times by 2 equals 3.4 centimeters. So it will be like a big jump to make 4.2.
Tony, what do you think about his challenge to your estimate? Do you think he's right? Do you think you want to reconsider your guess?
Yeah.
We actually chose the group, so sometimes we had an able knitter with an able mathematician, and there was lots of support within the group. But they were all working independently at their own level.
We've completed our 6 minutes of knitting. So now what we're going to try and see is what the actual amount is, and then maybe some of you can actually work out mentally the difference between your estimation and the real amount, okay?
Finding a real context for estimating, predicting is quite hard. Usually it's done on the sports field, that's one of the things, or perhaps it's occasionally done with weight. But here this was done in a very enjoyable way, and actually there was something to show for it at the end too, which I think is always lovely.
Professional knitwear designer Sasha Kagan explained how maths is integral to her craft.
Maths is the basis of knitting, really.
Sure.
You've got to know how many stitches to cast on, how many rows to do.
Right.
And as I said earlier, you know, your tension square, how many stitches to an inch and how many rows to an inch. That's all to do with numbers.
The amount of teaching that you can actually pull out from one of your designs is absolutely amazing. I saw reflective symmetry in one of your patterns, and you've rotated some of your shapes.
It's so interesting talking to you, because you can explain to me what I'm doing.
Right.
Because what I actually do is do it by intuition.
These shapes relate to some numbers. I'd like you 3 girls to have a look at this one and see if you can work out the pattern that I used to do that one. And I'd like you boys to have a look at this, you 2 boys to look at this one and work out what I did for that one. So we've got 1, 2, 3, 4, 5 going this way, and 1, 2, 3, 4, 5 going that way. So how many shapes are there inside?
25.
And how did you work it out?
5 times 5.
Well done. 6 here, which makes 12. I'd already knitted some squares which showed the 5 times, the 6 times and the 4 times table. And I gave the children the knitted pieces to look at, and they had to work out how I'd knitted the pattern. And they were able to work out by counting, and then we were also able to work out areas, perimeters of the shapes as well. I managed yesterday to knit a triangle. What do you think I did? What do you notice about what's happening to the stitches?
Is it by you've done one line and then the next line you've lost a stitch from both ends?
Good. Can anybody think what other shape it might be possible to knit?
I think it would be very interesting to get the children to actually write their own instructions for how to construct a triangular piece of knitting. And I suppose the easiest would be to start off with a right angle triangle. And a right angle triangle would definitely give you triangular numbers. What might be quite interesting would be to work downwards. So starting with a full row and then working downwards, taking one off each time and exploring the triangle numbers that way. Then, of course, what happens if you put the 2 pieces together? But that's another story.
So now what I want you to try and do for me is this. Can you work out the total area for the large square that you made as a group earlier, okay? And what was your answer?
5,625.
Right, now what unit of measurement should we be using?
Centimeter squares.
Good boy. Why are we using centimetres squared and not just centimetres?
Because centimeter squares were multiplying it by itself, but in a perimeter we're adding it.
This is lovely because it's a very big activity and children actually really like working with very big things. The pattern is very obvious, but because they're not totally precise, we don't have to worry about making them fit exactly. We've got lots of opportunities for them to get an idea of approximation, and they're sucking the structure out of the problem without actually getting really hooked into whether things are in absolutely neat and tidy rows.
Well done. So now can you try and make me the fattest?
The children went on to investigate the properties of other rectangles.
Will the area of this new rectangle be different to the area of the other rectangle that we made earlier?
I can think of hundreds of activities to do mathematically with these. What about looking at starting with something and arranging them in a symmetrical pattern? Could we have something which has line symmetry? Could we have something which has rotational symmetry? Does it have to be a rectangle? Could it be a cross?
This morning we're going to think about sorting some knitted garments according to mathematical data. Can anybody think how we could do this?
By weight?
What would we put at one end of the scale and what would we put at this end of the scale?
From heaviest to lightest.
I'm going to choose about 4 children to come out and choose a garment, and I want you to stand where you think the garment would go according to its weight. I wonder if you can make an estimate how much this one weighs. Remember, an estimate is a good guess.
500 grams.
It would make an ideal start, an ideal introduction to the whole topic of knitting, or obviously weight. Weight is notoriously badly taught. I think it's also notoriously badly learnt. It's very difficult to learn to estimate weight, and that's of course because there's nothing visual. So having something like this with a real context for it is really important.
250 grams.
Correct, well done. So can I just ask, now that we know Amber's scarf weighs 250 grams, does that give you any more information or help about how heavy Haroon's hat might be?
150 grams.
I wanted to make the children aware of the different weights of different knitted articles, and the largest articles were not necessarily the heaviest because of the different weights of yarn that had been used. So, can you tell me something about the relationships between those 2 garments? Manisha.
250 is half of 500 grams.
I quite like the idea of simmering activities, things that you set up or pose some question at the beginning of the week, and the children then ponder on this for the rest of the time. And this would be a fantastic simmering activity because she had a big box of clothes, so she could have done some ordering of things, got the children to estimate what she thought the weight was over the course of the week. It's a bit like the equivalent of how heavy is the cake that you get at the village fair.
You've got to think of your costing all the time. So, you know, how much is the yarn going to cost? How many balls of wool does it take? If it's really thick wool, then you're going to need, you know, not so much as if it was fine wool. And then the size of the needles depends on the size of the yarn. I mean, the maths, you could pull out all kinds of stuff for teaching, yeah.
I brought with me this morning one of my favourite knitted garments, okay? You're going to try and work out how much it would have cost to have made an item like this. In order for us to actually work this out, what help do you need from me?
You have to figure out how much money you have to give to them.
Perfect. I'm going to have to pay them per hour.
How much wool it would cost to make one of this stuff.
So, the needles, a pair of needles cost £2.40.
Isaac is actually modelling problem solving, a real life problem, a real context for a real life problem. And I'm sure that Sasha, the designer, would have supported that sort of problem solving method because those would be all the sorts of things that she would need to know.
To make one sleeve, it took me 2 balls of wool. So to make just this section... We looked at the amount of time the knitter would use to actually make the garment. We looked at money, we looked at measure, we looked at symmetry, and the children were able to identify line symmetry right down the middle. So if we know that it took 4 balls of wool to make the left-hand side, what can we say about the amount of balls it needs to make the right-hand side?
It took 4 balls also.
And how many balls of wool do you think you need to make the back?
One side of the garment is 4 balls, the other side has to be 4 balls also. So if you add it together, it makes 8 balls.
Well done. One more thing. It took the person to knit this, it took that person 5 days.
Is it all day long, really?
Very good question. The person actually spent 7 hours per day knitting. So I want to know how much it cost to make my complete item and how much money to pay to the person who made it. Off you go.
I thought Isaac scaffolded the children's learning through this very well. He helped them to understand what the important questions were to ask. Might have been interesting to see what would have happened if he hadn't asked any questions and that the children had had to pose all of that themselves. And this is the balance that the teacher has to have between scaffolding the children's learning so that they can't go wrong and giving them the freedom to go wrong so that they then remember what they've done that turns out to give them a right answer. I'm sure quite a lot of those children would have been quite capable, given time, of coming up with the same solution. The interesting thing was that they would have probably remembered it much more because they would have generated it themselves.
Knitting gives every child a chance to shine. Often children who are not particularly good at numeracy would be able to do something with knitting. They're actually using numeracy in a practical way.
So there are lots of other passions and hobbies that could be indulged by the clever primary teacher in the classroom. And as long as you check out health and safety first, really, the world's your oyster.